Okay, now we're going to go over outlier detection. I went ahead and ran the packages and load data in the last video, so if you skipped that video, go ahead and do that now. And then I have this code here that you can run, and it gives you an example of a correlation line with no outliers, and then the same graph with outliers. So if you look at these graphs carefully, if you have a significant or sufficient amount of data points, then outliers shouldn't affect the estimate of the correlation that much. The slope of these lines is not actually that different from each other. What having outliers in your data set does the most is increases this area of standard error, and that makes it less likely that you're going to find significance because not all of your data fits within this pattern that was identified. So that's why it's important to look for and remove outliers. There are a couple different ways to detect outliers. First is to just do the min and max values, which I went over in the last set of videos, descriptive statistics. So the next version is to plot a scatter plot. To do that, you can just do plot x value versus y value, x value comma, and then the y value. And it gives you a scatter plot like this. Since a lot of the data in this data set is ordinal on a scale of 1 to 5, there isn't going to be very many outliers because it was restricted to the values it can be. So there aren't any outliers here, but given a scatter plot, you could potentially detect outliers if they were there. Okay, another method is to use an outlier detection package. So here's an example on the data set that I used to graph with the outliers. And it gives you this cool graph. It identifies the outliers in red, and then it tells you what rows the outliers are in so that you can remove those if you want from the data set. Okay, so now we're going to see if the age variable has any outliers using the outlier detection package. Age is one of our few numeric variables that could potentially have outliers. Okay, so we're going to do outlier detection and then we'll tag our data. But when you run this, you'll see that there's an error because to use this package, x must be numeric. So now I'm going to give you the code to select only the numeric variables so that you can use this package when you have non-numeric variables. First, we're going to name our new data set that only has numeric variables in it. Then we'll use the tidyverse to do select if. We'll tag the data, and then we're going to select if it is numeric. Okay, now if you see up here in our environment, we have a new data set. It removes some of the variables that weren't numeric variables. Now we'll put this data set in here. And as you can see, there are no outliers in this. Okay, so if you do have outliers, what do? Outliers that are actually correct measurements, you should just leave these in. That means that if these were actual measurements, that this pattern doesn't explain all of this data very well, and that's a correct inference. But a lot of times with outliers, it's data entry errors or an error of whatever you use to measure something, perhaps like a faulty scale, something like that. And if that is the case, then you should definitely remove those outliers. So I wanted to show you how to remove outliers if you needed to. This refers back up to this data set right here that had these two outliers in row 24 and 25. And I tagged the data set that I'm going to just save over and then grab the data set that had the outliers. These little brackets mean which, so I'm grabbing the data which. The negative is not, so is not. And then I did a C, which just means concatenate. It means I'm selecting more than one value. And then I put the two values separated by commas. You can do more values if there were more outliers. You would just add the rows in like this. Everything that comes before this little comma is rows. So select which rows, and everything that comes after it is going to be columns. So select which columns. So since we're removing rows, it's going to go before this little comma right there, and then you can go ahead and close the which brackets. And if you run that, then cars now has 2 less observations than it originally did. You can see in our environment, which means that it removed the outlier cases.